Okay.
Okay, so you already got the basic idea that what is magnetic field, right?
Yes, yes.
It is a type of a kind of a region, we can say that, because these fields are invisible in our daily life. If we place a magnet, so we are not able to see those fields. We can just experience that field by placing another magnet near to it. Let's suppose if we have a table and we placed a magnet over it, and we just simply drag a thumb pin near to the magnet. So at that point, or we can say that at a specific point, a thumbpin automatically got attracted toward the magnet. So we
Yes, yes.
observe that this is the region, or we can say that from this point, magnet can easily apply force of attraction on that thumbpin, right?
Yeah.
Just like the cricket ground, just like the football ground, there are boundaries, and we say that this is the field or this is the region, right? all
Yes, yes.
all game and all score are going to be count over there within the field. So same goes for the magnetic field. There are some properties which is very much important for the magnetic field, because we know that we are having two poles, north and south pole, right?
Oh, yes, yes.
So let's suppose if we pole over here, and we are having a south pole on the right hand side.
Okay.
So there is always a single direction. So magnetic field will always from pole, right?
Yes.
So the very first important property is that magnetic field will always flow from magnetic field means will flow from north to south pole. It means we can say that from north pole a field is radially outward, right? Because it is coming out from the north pole and it is moving towards the south pole, right? Radially
It is what?
inward for south pole. uh, there are two terms, because in MCQs or in question they used to use these terms, and these terms are for north pole. Let's suppose if we are looking for north, and let's suppose we are asking that what will be the direction of field at north pole, right? So we can say that the field or direction of field is radially outward.
Your voice is again, I can't hear.
Wait a minute. Okay, now is it clear?
It gets clear, but then when you talk again,
Uh,
it gets fine for me.
Okay, so I am saying that whenever, let's suppose they talk about North Pole, right?
Yes,
And let's suppose they are talking about what is or what will be the direction of the magnetic field from North Pole, right? So you may just
yes.
simply write in one word that it will be radially outward, right? It is coming out
Okay,
from the North Pole, right? Because it is moving from north to south. And if they are talking about specifically for North Pole, so you may just simply write radially outward.
okay.
And same for South Pole, that if they are talking about the pole, so you may just simply radially inward.
Inward. Okay.
And most of they also used to ask about the diagram for the magnetic field, that like in MCQs we will got the question when we are solving the question, so we will observe the question that they are talking also asking about the direction or the pattern of magnetic field, right? Because in the
From both
first,
north and south pole.
yes, because this is our
Okay.
first in which we only discuss that a field is moving from north and south pole, right? From north
Okay.
to
Yes.
south pole. And one more important thing, The second property, we may write it for the magnetic field. These lines will never intersect each other, right?
Yes, yes,
That is all very magnetic field lines never intersect each other.
interesting. And they will, are they always going like in the straight line or like that upwards?
Yes, they will never intersect each other. And when there is a strong magnetic field, right? Let's suppose if we have a strong magnetic field, so lines are close to each other, right?
Yes,
That
yes,
shows you a strong magnetic field. And when lines are very far away from each other, so it means there is a weak magnetic field, right? We will also discuss
yes,
this concept in the chapter of electromagnetism, because this concept can be uh, observed over there when they are talking about that current is passing in a conductor and the magnetic field is going to arranged over there. So that is
okay,
important over there, right?
okay,
And one more
yes,
thing,
yes.
since we are talking about their thing, so all magnetic field lines are equally spaced, right?
But then if they're closer, you said they're closer, they're more stronger,
Let's
something
suppose,
like.
yes, if we are talking about a strong magnetic field, so the distance between strong magnetic fields are same, right? And if we are talking about the weak magnetic field, so the distance between the weak magnetic field is also same, right? Because since we are talking about magnets, so we know that the magnetic field will be constant. When we are talking about electromagnetism, so the concept will be different, right?
Yes.
Since we are talking about we can say that uniform magnetic field, right?
Yeah.
And one more thing, let's suppose if we are having two magnetic poles, once we already drawn for north and south pole, let's suppose if we are having a same pole, right? Let's suppose we
Yeah.
are having north and north and we are having south and south. So let's try to solve that one also, that what will happen if we are having north and north and south and south. So let's suppose if we are having a north pole over here
Okay.
and we are also having a north pole over here. Now we know that both will repel each other, right?
Yes, yes.
But the most important thing, first we need to know about their direction. So we know that the direction for the north pole is radially outward, right?
Yeah.
So when the magnetic field is coming out from the north pole of the left magnet and the magnetic field is coming out from the magnet from right hand side magnet, so they both will repel each other in the way like this. So this
Okay.
is the type of pattern we are getting from both north pole of both magnets, right?
Yes.
And both are again moving in outward direction,
Okay.
because we know that they will intersect each other.
Yes,
So
yes.
they will repel when they are very close to each other. And from the back side, we know that it is radially outward. So again, it is moving in radially out direction, right?
Yes, yes.
And let's try to see also for South Pole, because these diagram pattern are very important, because in MCQs or in question sometime like in detailed question they ask you to draw the direction only, like arrow, that in which direction the field are going, right? Because there is
Yes.
only a difference of field line, right?
Yes,
If we
yes.
draw the same diagram, but arrows will be in opposite direction, so that will be for the south pole, right?
Outwards.
Yes. because when we draw a south pole and a south pole of the second magnet, so field lines will be in different direction. So we will draw the same pattern, but the arrows will be different direction only, like this, radially
They'll be
inward.
the opposite one.
Yes. Again inward, inward, and from the side we also inward. So these are the type of pattern for north and north pole, south and south pole, right?
Yes, yes.
And for north to south, we know that both will move from north to south pole.
Southward, yes.
For north, it will be radially outward. I will also share the detailed diagram picture with you, so that will give you a clear idea. But for the basic concept, you need to know that how they are going to work in the direction of magnetic field when same poles are placed with each other, right?
Yes.
And we can easily identify their strength. We may also write it over here for your reference, that strength of magnetic field or strength of a magnet can be identified with the help of the distance between field lines, right?
Yes, yes.
And how we can identify,
The distance.
yes. So if field lines are close, let's suppose if field lines are close to each other, so it means
This strong.
strong field, right?
Yes.
And let's suppose field lines are from or not close to each other, so that gives you the indication that there is magnetic field. So this is for a strong magnetic field and this is for a weak magnetic field, right?
Yes, yes.
So this is the concept for a magnetic field. And you also learn or you also observe the basic experiment in the lower secondary classes, that if we place a magnet over a paper and we place some iron fillings near to it, so
Yes, yes.
and we place a compass near it, so that will also give you the direction of north to the south pole. So iron fillings will also arrange in the same pattern that we already
Yes.
discussed in these diagrams, right?
Yes.
That is also a experiment related to the magnetic field, but since we are not going to perform any experiments, so
Yeah.
we just use the reference for that. We already studied that. The one more important thing is for magnetic field, because since magnetic field are not visible by our, or we cannot observe by our normal eye, so we use compass over there to identify the direction of magnetic field, right? Let's suppose if we
Yes.
are having a north pole and are having a south pole, so magnetic field lines are moving from north to south. and radially inward from the backside, and radially outward from this side of north. Okay, let's suppose I'm not drawing a detailed line over here because we need to focus on the compass. And let's suppose we placed a compass over here and one compass over here, right?
Yes, yes,
Okay, and you observe that in compass we are having a red point and a white point, right?
yes, yes.
And red point basically represents North Pole.
Not, not.
Yes. And the white basically represents the opposite direction, right? So let's suppose if we are talking about, let's mark them number 1 2 3 4. Let's suppose this is compass number 1, this is compass number 2, this is 3, and this will be 4. So if we are talking about compass number 1, so in compass number 1 we know that the north direction of the field line is from left to right, right?
Yes, yes.
So in the compass, we can easily mark the point like this, that in this direction there will be a north pole, right?
Yeah.
And when comes towards the point or compass number 2, so it will be slightly downward because now we are close to the south pole, right?
But why will it be like down? Like the before one will be like that
Because
side.
we are starting from this point, and since it's the south pole, so it is going in down direction, right, towards south. So that's why there will be we are moving a compass from position 1 to position number 2. So compass or the direction of compass will also move in the direction of magnetic field, right? Just like we draw from north to south pole like this. First it is
Oh,
start
okay,
radially outward, then radially inward towards south. So that's why it is start rotating also, right?
okay.
And if we talk about position number 3 and position number 4, so in position number 3 again it will be radially outward, so it will be in this direction because we are starting from north, and since at
Yeah.
position 4 we are close to the south pole, so it will
Yes,
be
so a bit
radially
up.
inward, right?
Yes.
So this is the concept, right?
Okay.
Because this compass direction is also very much important, because in questions they used to ask for the compass, that how or what will be the direction of the field line when we are moving from this point, or if compass is placed at this point, what will be the deflection in the compass. So they used to ask this question also,
Okay.
so that's why it is important.
Okay.
So, and we also know that if we need to find out the magnetic field, if we ask that how we can find out or how we observe the magnetic field, so answer is very simple, by using the help of compass, because compass is the only material that we use to identify the magnetic field, because magnetic field are not visible by normal eye. So that's why we
Yeah.
use compass, right?
Yes.
So for magnets, we discuss about the strong magnet, weak magnet, permanent magnet, temporary magnet, right?
Yes.
And we also discuss about the magnetic field. It will always flow from north to south direction, and radially outward from north, radially inward towards south. And
Yeah.
we also discuss the methods, that it can be electrically magnetized, it can be magnetized by a method of induction,
Yes.
and some other starting example are very common. And if we talk about that electromagnet, the first method, this electrical method, it is also known as electromagnet. So let's say if we talk about electromagnets, electromagnet means that those magnets which are made from electricity or electrical method, right?
Yeah.
So that is also a very simple term. So normally electromagnets we used in our daily life. If they ask you that where we are going to use these electromagnet, In our daily life, we are using in MRI scanners, right? In
Oh,
hospitals,
yes, yes.
they don't to talk about their explanation that how we are going to use these electromagnet. We just need to know about their uses in our daily life, because in MCQs it will help you. And very common example is speakers and headphones, right?
Yes, yes.
So magnets are also used in speakers and headphones. Plus, when we are working in recycling, the same example of that crane, right?
Yes,
So when we
yes,
are working with recycling material, so electromagnet also that also help you to separate the magnetic material, right, from the normal paper or from the cardboard, right? And
yes,
nowadays in developed country, we know that we are using the bullet trains. So in that purpose, we also use the bullet trains. We also use the concept of electromagnet, right?
yes.
That works on the electricity and magnetism. So these are type of
They won't ask like how they are using trains and
no, they
scan.
don't ask
Okay,
about how. They only talk about that name or state the
okay,
examples, because this section is not much very detailed. Electromagnet is very much detailed when you are going in your A levels. So in A levels, there is a detailed concept of MRI scanner and all X-rays, and so in that specific level, they ask about whole concept, that how and it happens and how
okay.
we are going to use, right?
Yes.
So any other question, any other confusion?
No, it's not. It's clear.